So as we spend a little bit of time looking at those three elements right there, what we want to do is illustrate one, the Bohr model, okay, and then two, we'll do the configuration for those, and we will save the orbital diagram for not necessarily another time, but for next week. So we still use the slide rule to complete this task, if you want to call it that, or these tasks, and hopefully we don't make them Herculean tasks. At least they hopefully don't appear like that. So let's go ahead and start with that bromine and follow your slide rule. Okay, so if we're doing the Bohr model for that, here's our nucleus, okay, and the first energy level, shouldn't be no surprise, we go 1s2, okay, then where we go, 2s2, 2p what, okay. Now, all of these numbers should add up to what? 35. Should add up to 35, okay? So we're up to 10. Then, next energy level, we know we're in 3s. The big 3 tells you what energy level you're in. The S tells you where you're at on the periodic table as well. Not just the period, but the energy level as well. So 3s2, third energy level, S block, which holds 2. Then again, you skip across over past the D block. We're not quite that far yet. Here we're just at sodium right now. So we've gone 3s2. Then what comes next? 3p6. Okay. So right now, if we stopped right there, what element would we be referring to? Argon. And one way to make mental note of that is, since we got 8 here, that means that's in the 8th column. Remember, 1, 2, then 3, 4, 5, 6, 7, 8. Don't go by these 10 because they are transition elements. And we've seen examples of that. Copper is an example. Iron, cobalt, nickel. When you look at any one of those atoms on there, what's true about their charges? They have multiple charges to them. You can even look at manganese, or that has 4 different charges. Chromium's got 3 different charges. And those are the those are the main ones that have more than one oxidation state or charge. Okay? So now we're up to 3p6. You keep going down your slide. You're probably about down to here because it went, let's say 3p6, and then down here is what? 4s2. So the 4 is saying we need a new energy level. Okay? So then going to the top of your next slide is telling you what? 3, gotta go back down to the 3rd energy level. There they are, all 10. Okay? Now keep going down your slide, and you're probably about right here. It says 3d10. You keep going. What's probably in the next one in the vicinity? So 4p6, 1, 2, 3, 4. And will we put all 6 of them in there? No, 5. Okay? So let's just double check. Okay? So we got 10, 20, 28, 30, 35. That matches our protons then. And notice what happens when you take 2 and 5 and add them together. What do you get? 2 and 5 added together, you get 7. Okay? So that tells you what column is bromine in, the 7th column. This also tells you what column it's in. All right? So a couple things that we can do to help this periodic table also helps you with is what period is bromine in. Remember the periods are along here. Here's your periods. Okay? So we find bromine and we see that it is in the 4th period. Okay? So we know that that ends in the 4th energy level, and then in that 4th period, the P block can hold how many? 6. But what column in the P block only is bromine in? 5th. Okay? So that's where that number comes from. So by knowing your periods and the last electrons to go in, okay, that will tell you whether you're doing this correctly. And that just comes with experience. Okay? Any questions over this? Yeah, sure. You can do that. Yep. Probably the biggest thing is notice, make sure you get 35. So notice what would happen if we did this. That's just another electron. Then we're going from bromine over one more. Now this column, or this last energy level, is now full. But now it's got 36 electrons and only 35 protons. So therefore, it's got a charge of what? -1. Okay? And notice we got 35 positive charges. Now we've got we add them two together, and what do we get? -1. What does it say inside bromine's box? It just has a negative sign. That means -1. And that's why we see that. This wants to gain one more electron. Then it stabilizes itself. Okay? That will become more and more evident when we start doing those dot diagrams as well. If you remember those from 2 years ago. Okay? Just to make things, remember we had H and Br. Okay? Notice we've got 7 valence electrons. Here they are. And we've already established it wants how many more? 1. Then the outer energy level then is full. And that's where it gets it from, is the hydrogen. Now that's a little bit down the road, but this is why you had learned this in physical science, and then when we take it in chemistry, we're ready to go. Just like we said walking down the hall, we're ready to slide right into this. See, Jordan, you'll find that funny. She's going to listen to this and say, wow, that was so funny. You'll. Okay. All right. So, all right. So, if we were to do the electron configuration for that, that's just a linear depiction of what the Bohr model is. Okay? Can you take a shortcut for this? Yes, you can. And we'll show you what we mean here. Okay? So, in other words, we can just do this linear depiction, bromine 35. We do 1s2, okay? 1s2, comma, follow your slide rule, go up to the top of the next slide and slide down. 2s2, that's this one right here, 2s2, and second energy level, P subblock, there's 6 of them, 2p6. Might run out of room here. Notice the commas are separating the energy levels. So then what comes after 2p6? 3s2, there they are. Okay, follow your slide down. What comes next? 3p6, there they are. Okay. Then this is where it gets to be a little tricky. This does not come next. Your slide rule accounts for that, or Afabu principle. That's one of the things we had discussed yesterday. We don't go 3D10 next. Your slide rule says 4S2 goes next, which it does. Okay, there's 4S2. Then what? 3D10. Then what? 4P5. There they are. So, yep, we're just going to have just enough room. 4P5. So if we add all them exponents together, surprise, surprise, you're going to get 35. Surprise, surprise, 35. Yeah. Huh? So what we mean by a shortcut is what is the next lowest number of noble gases, lower than bromine. Means that you can't go up, you got to go down. Argon, so what we mean by that is we do the electron configuration for argon. Notice we're going to do 1s2, 2s2, 2p6, 3s2, 3p6. Notice we're just doing the same thing over and over again, aren't we? So one of the examples that I think you probably remember is if we had, for instance, 3x squared plus 6x minus 9, do all of those have something in common? How could you simplify that? We could even say equals 18. How can we simplify that? Well, we're not solving for anything, we're simplifying. What do they all have in common? They're all a factor of 3. Okay? So we could, now we're not solving for anything, we're just simplifying by saying if we factor a 3 out, then what does that leave here? Minus. Okay? So what we're saying is we're taking a common factor out of there, kind of like what we are doing here. We're factoring that out of there. Okay? So then what that allows you to do is say, rather than writing this same thing over and over and over again, since we know that argon has an outer energy level that's filled, which it does, okay, because 3s2 and 3p6, we can prove that by looking at your table. Okay, if you looked at that 3s2 and 3p6, 2 and 6 gives you 8, right? If we look at this, 2 and 6, that gives you 8. So we're going to factor all of that information out of there and say we're going to use an argon or noble gas core. We're already up to 18. So what do we have left that's in the orange? Okay, 4s2, 3d10, and 4 what? We can always check that and say, here's 15, and 2 gives you 17. 17 plus 18 gives you what? Okay. 20 and 15 together gives you 35. So this is just a shorthand representation of what the configuration for And we had done that when you were freshmen, but we just didn't go this fast. Okay, because that's one of the things that we want you to be conscious or aware of, is that when you are doing this the next time you see it in college, you're going to be moving at a pretty good rate. You don't have that opportunity to, well, of course you can ask questions during lecture. Yes, I advise you that you ask multiple questions. But the professor or the teaching assistant is going to be moving right along. And if it's one of them things to where you need extra help, that is your responsibility. So that's why we try to put that on, for instance, your shoulders and say, you are responsible for this information to a certain extent. That's why we say, come in and talk to us before school, after school. Find a senior that knows how to do this. Or maybe even another teacher knows how to do it as well. You have a multitude of opportunities at your disposal that can help you with this. All right. Well, I was going to go a little further, but is there any questions on this? You'd have to make another energy level, but yeah, that would not be possible. To form positive charges you can, but you got to be careful if you're doing negative charges. Yes?
So the AR-18, that plus the other things on the outside equal bromine?
Yes.
Oh, okay.
Yep. Because if you add these numbers together, it gives you 35. You can only use a noble gas in here. It has to be one that has an outer energy level that's filled. In other words, if we're up to, notice that this level is full, okay, so that must mean we're talking about krypton now. Because krypton is in the 8th column, right? And it's a noble gas. So if you're dealing with anything bigger than a krypton, which would be anything in the 5th period. Now, let's see if we remember from yesterday. This is 5s2, but once you get over to yttrium and, oh, this print is so small, whatever ZR is, element 40, what period is this? Well, it's either 2, 3, or 4. Yes, I agree. Which one? No.
3.
Not 3.
4?
It's in the 4th period. Because remember, when your slide rule, when you get down to that spot, that's why we use that slide rule. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. Okay? So what that means, remember, is that this 4th energy level fills up before that 3d10. So that's why you got to be careful that, yes, 1s2, 2s2, 3s2, 4s2, but once you get to scandium, element 21, that is not 4d10. It's what? 3d. Okay? Remember, you got to subtract 1 with that. We said it wouldn't make any sense to move that up an entire block because you can't put scandium next to magnesium. Why can't you do that? Because you can't go from element 12 up to element 21. That wouldn't make any sense either. So that's why you use that slide rule to make that correction. Okay? So remember, you can use this to a certain extent, but if there's an element that falls in the D block, you have to subtract 1 from the periods. Does that make sense? Yes, because that's what this is telling you right here. Yes. Yep. We on the bus, left outside, left middle, right middle, right outside.
Yep.
We're all on the bus. Okay. Fair enough. We will continue with these other two elements in this information on Monday.